In lesson 7, we're going to do our simplifying square roots. So we want to write each expression in simplest radical form. So I'm not going to do this for all this, but we're going to focus on some of the things that multiply to give us each number. We'll write all the combinations out, identify our perfect squares, and then go from there. So what multiplies to give us 44? Well, we know 1 and 44 is never the right option. So the other answers are 2 and 22. We could have 4 and 11. And I'm pretty sure that's it. There's nothing else that breaks down and gives us 44. Well, between 2 and 22, neither of them are perfect. 4 is a perfect square, so the answer is 4 and 11. So we open up our diamond. Perfect square always goes on the left, non-perfect square on the right. So the square root of 4 is 2, and then the non-perfect square 11 stays inside. For 112. Now there are a lot of different things that multiply to give us 112. And if we remember our calculator trick, if we take the number we're looking for and divide it by x, that'll give us all of our options. So 2 and 56, 4 and 28, 7 and 16, 8 and 14. And as I look through, it seems like that's probably it in our combination, since it is. So if we look, neither of those two numbers are perfect squares. 4 is, 16 is, and neither of those. So now if we compare our 4 and our 16, which one has the bigger perfect square? That would be the 16. So square root of 16, square root of 7, square root of 16 is 4, square root of 7 just stays. For the last one, square root of 80, without writing out all the combinations, we have 16 and 5, square root of 16 is 4, and the square root of 5 is just 5. As we look at the next piece, 4 square root 45. All right, we're going to pretend like that 4 out in front isn't there for a second. We're just going to keep bringing it down. So we have square root 9, square root 5 with that 4 still out in front. Square root of 9 is 3. Square root of 5 just stays. And now what we have to do is we have to take the original number and the new number that are out in front, multiply them together. 4 times 3 is 12, square root of 5. If we remember, when we have the square root of a big fraction, it's really square root of the top over the square root of the bottom. Well, these are both perfect squares. So the square root of 1 is 1, square root of 9 is 3. So the square root of 1/9 is really 1/3. Same thing over here, except the negative sign is just going to be useless to us until the end. So 98 splits into 49 and 2, which comes back together to give us 7 radical 2. And we're basically just going to keep that negative coming down in front until the end, and then it has to just go in front of our final answer. Write the expression 6 plus square root 84 in simplest radical form, over 2. Now the biggest mistake people make is they try to cross out the 6 and the 2 right away. But again, you're not allowed to do that with that square root present. So the first thing you have to do is you have to go into your calculator and split that 84. And when you do that, you end up with your winning combination being, it looks to be 4 and 21. So square root 4, square root 21 comes back together to give us 2 square root 21. So what we're going to do is we're going to replace that square root of 84 with 2 square root 21. Now we can look at all of those numbers on the outside, and we can figure out what goes into 6, 2, and 2. So we can divide them all by 2. That gives us 3 plus, you could put 1 square root 21, or you could just put the square root of 21, it's up to you. And then you don't have to put over 1, so then our final answer is 3 plus the square root of 21. And then for the last one, we want to simplify. So remember, you can only add or subtract radicals if they have the same number underneath their square root. So if we simplify the 25 or the 125, it's 25 and 5 comes back together to give us 5 square root 5. The 20 is square root 4 square root 5 comes back together to give us plus 2 square root 5. And then 45 is 9 and 5, which gives us minus 3 square root 5. So when you add and subtract all these together, you're just really going to add and subtract your coefficients. So 5 plus 2 gives us 7. 7 minus 3 gives us 4. And then we're just going to keep that square root of 5 consistent, and it's just going to remain in our final answer. So remember, you can only add or subtract your radicals if they have the same exact number underneath.